All right, this is the review video for AP Physics Week 12. Here are the four main topics that will be on Tuesday's quiz. One, a review, specifically a review of energy conservation. So that's the initial final KE plus PE equals KE plus PE. And since this review is mixed in with the momentum conservation, you have to remember that this is for like falling down a hill or bouncing off a spring, whereas momentum is for collisions or two things flying apart. There will also be mechanical energy graphs where I might give you, say, a graph of kinetic and total energy, and then you would have to draw for me the graph of the corresponding potential energy. The impulse, impulse, which is a force times a time. And the impulse momentum theorem, which says an impulse is a change in momentum, in which case I need to indicate vectors. I'm indicating vectors because it may be important on the test that momentum is a vector, meaning direction matters, so pay attention to that. And finally, momentum conservation, which is that the total initial momentum is equal to the total final momentum of a system. And I told you anytime you see a problem that you realize is momentum conservation to just write m1 v1i plus m2 v2i equals m1 v1f plus m2 v2f. If you don't have that equation memorized, come Monday, you're going to do really terribly on the free response question. Let's go through each of these one at a time, but pretty quickly. Here we go. All right, first off, review. So let's say I give you a problem where there is a couple of hills, each one lower than the one before, and I say that I've got a ball up here with some mass m at rest until somebody just taps it enough to start it rolling down the hill. And let's say I call this height h and this height h over 2. Find the speed in terms of given variables of the ball when it reaches the second hill. Might be a question I would ask you. And I'm not going to do this question out. I'm just going to remind you that what you need to do is set up initial and final conditions. Kinetic energy plus potential energy at the beginning equals kinetic energy plus potential at the end. Now I know this is energy, not momentum, because there's not two things hitting each other or two things flying away from each other. That would be a collision problem and therefore momentum. This is an energy problem because it discusses an object being at two different places with two different heights, assumedly two different velocities. Also, if a problem discussed a spring and a height or a spring and a velocity, a good idea is to first think about energy conservation, even though it could turn out that it's momentum. For example, if I said two boxes with a spring between them are squished together and they fly apart, well, that's two objects flying apart, so that's technically a collision problem. But anytime you have a height and a velocity involved, or a spring and a velocity, there's a good chance it's energy conservation. So, two heights here. At the beginning, if that ball is not moving, which I said it was, not moving, there's no kinetic energy. Can't have kinetic energy unless you're moving. And at the end, because I'm not at my original height, I only have half the original potential energy, meaning the rest has to be kinetic. Then I've got PE equals KE plus PE at the end. And then I'd plug in the equations and the variables. But that's the basic idea of how you do energy problems. Next thing you're expected to know about are mechanical energy graphs. So let's say I gave you a graph of energy in joules versus position in meters. And I said an object's potential energy looks something like this, with a total mechanical energy here. That should be a straight line. Draw the object's kinetic energy. Why don't you take a second and maybe on your notes page try that real fast. Pause it and draw the corresponding kinetic energy. Corresponding kinetic energy. And if I've drawn it perfectly, everywhere the two heights of the potential plus the kinetic would get me to the top. I have not drawn that perfectly. Clearly that red plus blue would not get me to the top. But you get the idea. Just remember that potential and kinetic energy graphs are generally the opposite of each other, but then remember to check them. Like I've clearly messed up this red one here. I could do a much better job and try to do a purple one that's a little better. So I start out maybe more like that. Yeah, I think that purple plus that red might get me all the way to the top. Anyway, your two energies, potential and kinetic, always have to get you all the way to the total, and the graphs are generally the opposite of each other. So keep that in mind. We did a bunch of these in class. I think you'll know how to do them and be just fine. Moving on. All right, impulse and the impulse momentum theorem. Impulse is force times time. So anytime a force happens over a period of time, that's impulse. And if you're given a force time graph, something like this shape here, impulse is the area under the curve. If you have a non-constant force, so remember this equation implies a constant force. Anytime you have a non-constant force, and forces in real life are non-constant, you find the area under the curve. And then the other thing you need to remember is the impulse momentum theorem that says that impulse is a change in momentum. And that momentum is a vector. Remember that, definitely. Direction matters. Yeah, that's it for impulse and the impulse momentum theorem. On to the next one. All right, momentum conservation. So first of all, if you have not already, and I've said it about 5 times now, memorize m1v1i plus m2v2i equals m1v1f plus m2v2f. Memorize it right now if you haven't already. Anytime you see a momentum conservation question, you're like, that's momentum conservation, just write this down and then go from there. In fact, I would even avoid trying remembering like different arrangements of it. I know some people caught on that if they move with the same velocity, you can just write m1 v1i over the two masses or whatever. Write this down and then see what's happening in the situation. Whenever you know it's momentum conservation, just write this down. I also have a recommendation for you. On the website, I have put right below this video the free response question from the 1976 AP Physics exam, free response question number 2, which is the one we started in class. So we did part A in class, and only one group had time to try parts B and C. I recommend that you go to that question right below this video and do all parts, even part A, just to make sure you can do part A on your own when not in a group. If you really want to know the answers to the different parts, you can text me or call me or come on Monday and ask me. I'm not going to post them on the website because the person who gave me all the rubrics actually asked me not to post them online. But if you would like to know the answer or know if you got it right, you can just check with me. All right, that's all. Rewatch any parts of the video you need to. Try the free response question. Make sure you look at the Princeton review pages I've put up, and make sure you do the Veterans Weekend assignment, and you should be ready. See you Tuesday. Have a good rest of the weekend.